Hi, good afternoon. Uh, we start the session called Disruptive Technology in Smart Mobility. I will try to be, I will be brief. In the times we're living now, we have a lot of challenge to try to first of to achieve uh, implement policies to reduce or fighting against the climate change. Thing is, this one tool who can be really useful is using the technology in the cities to transform an advance in the in the situation we have to fight about emergency who ask for emergency management. I introduce the speaker. First, Ana Luz Jiménez Ortega. I think everyone knows Ana Luz. And big professional, director of traffic in Seville and coordinator in Andalucía. José Roca Toa, managing director, CEO, Airbus, located in Barcelona, and Francisco Simón, business development director in Skylife Engineering. You can start.
No.
Okay. Oh, I think now it works. Okay. So, good evening, good afternoon. In this talking session that we have prepared, I'm here as user of technology to achieve the goals or to face the challenges that we have in mobility nowadays. As the slogan of the Congress said, we need that mobility becomes clean, sustainable, of course, safer. But we have a very important word, as Diego said, that is mobility has to be resilient. We have to face challenges. We have experienced some situations that we cannot imagine, maybe, and we have to be prepared because the only way to have a right answer to this situation is we need mobility to face them with guarantee of success. In that way, technology is the best partner to achieve these situations, and disruptive technology can help us as users or public responsibility for guarantee this mobility. We were talking about what type of technology can help us to achieve our goals. And I think that this roundtable has very good colleagues to introduce what is coming and how can it help us to achieve our goals. So, please.
Thank you, Ana Luz. Can you hear me okay? Yes? Great. So, so I work at Airbus, and we are one of the known players for developing technology, particularly in Europe. And the area I'm coming from is Airbus Defense and Space. So the disruptive technology I would like to share with all of you today is actually coming from space. And there's a very strong drive that we have used to develop this technology, which is, among other things, the current societal and geopolitical moment that we are living, where we are more and more requested to be able to provide technology to react on very short notice to different type of emergency situations that we are facing, like the ones you were making reference to, Ana Luz. So it's something that may surprise you. Some of you may already be familiar with it. But when we look at mobility today and the different sources of data, I've attended a few of the discussions talking about all the different sources that we are talking about connectivity or also geospatial or geoinformation. We seem to rely on satellite connectivity, satellite images, but also we are complementing this with terrestrial networks and terrestrial-borne data. And I think you're going to talk about some of this terrestrial data as well. So both from space and from the terrestrial network, there's opportunities, but there's also challenges. For instance, if we think about a satellite taking a picture at a given moment of time in a huge traffic jam that may have appeared somewhere in the territory, we have a picture, but then because of the revisit window, this satellite is living, right? Because it's following the rotation of the Earth. So then we may have very good resolution, we have a global reach, but then the satellite is gone. How do we complement that? So we complement that with terrestrial-based solution or aerial solutions, right? With drone imagery, with drone connectivity, with LiDAR, with sensors ground. However, if we think about a drone, once you need it, you deploy that drone tactically, and after 1 hour or 20 hours, depending on the type of drone, the drone is gone. So if you still have your situation that you're trying to manage, then you've lost the data. So we need to find disruptive technology that is helping us having both a global reach, persistence, and resolution if we talk for geospatial. And this is where these type of solutions they come in. So it's called HAPS, High Altitude Platform Stations, and it's platforms or drones that operate in the stratosphere. So just to give you a little bit the different layers, we have the outer space anywhere in the geospatial arena. Then we have the stratosphere at 21 kilometers high. And then we have the aerial solutions in the normal airspace. So this type of, let's call them drones, it can be either fixed wing or it can be maneuvering balloons. You may be remembering we had an occurrence in the United States, right, a few years ago with this famous spy balloon that was neutralized. So this is a HAPS. So a HAPS, it's not visible to the naked eye, and it can confirm and bring this persistence, so this continuity in the transmission of data. And we do talk about real-time data. So this is data that is being sent continuously to wherever you have in a specific situation that you need to handle. And it can either be geospatial data, so in other words, images and video, or connectivity data. For instance, this equipment can have a payload, which is a sensor suite, or it can have a 5G antenna. And then you ensure that there's no disruption in some of the use cases that Ana Luz was mentioning. I'm going to go very quickly just to show you that the disruptive technology is now becoming a reality. So we are not talking about science fiction. These platforms are actually starting operations. And we are in the process where we need to work with our users to escalate this solution commercially and try to see how this data can now be integrated into the networks of data that is already available for mobility solutions. So here you have the example of the takeoff, super simple, just a few guys running and then climbing to the stratosphere. I didn't mention it, but this type of platforms can be in the stratosphere for weeks and for months. And they can even be fixing a specific area of interest. For instance, when we faced in Spain the Dana, we needed to stay in that very specific region with not moving, with a very high level of precision. Or if you want to follow a target, if we have a specific situation related to traffic and we need to follow, for instance, a convoy. So this particular technology, it's like a drone where you can operate it remotely and then it just follows your area of interest if it's a moving. The same for balloons. So it can be a fixed wing, it could be a balloon, depending on the type of precision you need or the type of flexibility you need in the point of deployment. So this is some tests that we have done. Also with exactly the same payload as you saw in the airplane. So electro-optical sensors, infrared sensors, and 5G antennas. And then I'm going to go very fast. Just a little bit of the explanations also on the different types of resolutions we are talking about. So just to give you an idea, when we are in the stratosphere, we can go as close as 18 centimeters of resolution. 18 centimeters. What is 18 centimeters? It means that you can follow individual movement. And I think the best is that you see it for yourselves. So we say that one image is best than 100 words, right? Francisco. So this is a real image that we've captured from the stratosphere. And you can see the type of details. So it almost looks like a satellite image, right? Except that you have the movement. And a movement, it's really changing you, the way you address your problem. So just for Ana Luz, you see some...
Yes, for the...
It's really amazing, and it could be a disruptive technology to face situations like you mentioned when we have the eruption in the Palma. We used the satellite images to be integrated to follow because we do not have a sensor like this. It could be in this type of situation could be really interesting to provide sharp information to make the right decision in the right moment. So it's really impressive.
It's very interesting about the hubs. For example, that you can have a system in more or less in the same place, and you can have data from the Earth in real time, more or less. It's
Complementing.
completely different than the satellites, because in the satellite you have to spend the time that pass for the area that you want to analyze. And with the hub, you can have this system in the fly or in the sky. Sorry, during I didn't remember, but Zephyr is around 60 days or something more or less. Or
Yes, for
what
the
is
moment, our maximum, our record, it's 67
Ah,
days
67 that.
of uninterrupted operations, day and night.
That.
Yeah. So,
And
And,
thank you, Rousset, because I didn't know what is or what was what will be your presentation. But for example, Skylife is collaborating with Alto in the Zephyr development. So it's one interconnection that we have.
but we did not know about it before.
oh, yeah. Sorry.
So, Ana Luz, I have one question for you. If you had this technology, for instance, in a situation like we lived in Spain, where we all lost electricity for 16 hours, right? I see some nods in the audience. How could this, for instance, have helped us in this situation?
Well, it could has been a back real information to maintain, first of all, images, that's to know that everything is working like it should be, and specifically communications. I think that when you face a challenge situation, the first thing you need is to communicate with your equip, with people on the road to send the correct message for the correct situation, to control, to advise or what should be done or not. And this could be a really helpful tool to make decision and to keep connected. You can, I suppose, you can take an antenna in the hub.
Yes, so there's two use cases. There's the geo information or the geospatial. So for this, it means taking images. And for this, we have a sensor suite of different types of electro-optical sensors with different type of resolutions. But then the other use case, to your point, Ana Luz, it's equipping Zephyr with a 5G antenna.
Yes.
So a 5G antenna, it's like having a 5G antenna that you see in any building today. And the equivalent here, it's equivalent to 250 antennas, more or less. So you can make your math and try to figure out how much connectivity service we could do with that. So for the moment on the...
But the question that arises should be it's used nowadays in Europe. Can you provide this service?
I love this
now?
question. I love this question because we've had this technology. So we've been developing this technology for 10 years. We've tested it in the US. So we've done a 64 flight in the US, in all the border between the US and Mexico, all the way to Belize. We've tested it in Australia. We've tested it in Asia and in Africa.
That.
And the only continent that's left to test, it's the one where we are manufacturing and we are building this technology, which is Europe. And we are having a little bit of a hard time getting the regulation ready for us. So I'm sure it's going to arrive, but it's one of these examples, right, where we say, yes, regulation is not always going as fast as we would like.
It's unbelievable, right, Rousset, that we have developed and we have manufactured everything here in Europe, or more or less everything. And the last area that we are test or we are proof or we are using is in Europe.
I mean, it's going to get there. We are hoping of making the first flight in Europe this summer. and we are going to be in Spain. So we are working very closely
That-
with the worthiness authorities in Spain to give us. But this is, I mean, this is an example of
that
this technology. When we started developing it, it's no man's land. It's not terrestrial networks. It's not space. So there's no regulation that it's made for that.
that
So we are being regulated, use the drone regulation, but when you apply the formulas, it's giving you a reach that makes no sense for the concept of operations that we have developed. So it takes a little bit of education, a little bit of time and patience. We are almost there, but it has taken us a little bit of time.
It means it's really disruptive. You don't have to regulation. You are the first. But what would you need from the regulation? What is your idea scenario to implement this type of technology to be used in such situations like we have been talking about? What would you need for that?
So the way regulators in Europe are approaching this disruptive technology, it's to try to assimilate us to something they know.
Yeah.
And they're trying to assimilate us to airplanes and to drones where they have a very specific flight path,
Yeah.
and then you just follow your waypoints, right? But this is not why we have developed this technology. We have developed this technology because we want to have the flexibility to go in a specific area if there's an emergency situation, if there's a forest fire, if there is un apagón, right? So what we would need from authorities is for them to work with us to help us understand the design of the aircraft, the safety features, all the hours of flight that we have accumulated in all of these other regions of the world to give us the flexibility to be able to have freedom of movement in the stratosphere. And this is really the hard cookie right now. It's this freedom of movement that we would like to have, to be able to go to all of the use cases that you can think of. We don't think it's going to go as fast as we would like. We believe that the first limitation is going to be in dense areas of population, where they may actually ask us not to overfly dense areas of populations. But if we can, I mean, the Zephyr, if you have seen, it has 45 angles. So it's okay not to fly cities because we can still see in the cities by just steering electronically the sensors. So we need to work with the safety constraints because safety, it's non-negotiable for any of us. And we need to find a way of being able to have a little bit of flexibility to be able to go and allude to the places where traffic is demanding and you need our support.
But right now, well, no, as you say something similar about that, but for example, the authorities right now in Europe in general, in Spain specific, when you have any emergency, you can create a restricted area in the flight. The only that we have to change in the regulation is that when you sanction is the words, I'm not sure, but when you declare that this restriction area limited in the time on the time, you can use this type of system. With that, you will be able to use this type of system, and it's a easy change in the regulation.
Maybe the approach we have used for automated vehicles maybe is a right approach to the introduction of this disruptive technology. We need to regulate, we need to give general rules, but we need suppliers, we need manufacturers, we need developers to be comfortable and to try in a safety mode, of course. But we need to provide the correct environment to make tests and to then establish the general regulation. I think that's a Spanish use case for automated vehicles. Is a good approach, flexible, and nowadays, 10 years ago, in 2015, the first automated vehicle trip in open traffic was run in Spain from Vigo to Madrid. It's 10 years ago, so it's a long time for technology measure, but nowadays we have the reality of a shuttle in Seville running till the end of month to be proven by people. So I think it's necessary to give the opportunity to developers to try in a safe way, but to try.
That could be a good analogy. So what has worked successfully in autonomous driving for vehicles, where you have created these safe areas where regulation was a little bit more permissive to allow technology to progress and to be tested and to gather all the data, because at the end it's about gathering enough data so that you can convince authorities that your operation is safe.
Yeah.
It's a very similar example. So trying to identify these areas where regulation can be, or to your point, a little bit of a restricted airspace or segregated airspace scenario, where we could test this technology and help us finalize the acceleration into the commercialization, which is where we are right now. So technology is disruptive. We've accelerated. Now we just need to fly.
Yeah.
And to be able to provide you the data where you need it, right? There's a few more slides, but then I think you also would like to share with us some terrestrial disruptive information, right?
Yes. About my disruptive technology, I wanted to start with a video if you don't have any inconvenience.
Please.
Locating an asset, a device, or a person can make all the difference. In industrial, strategic, or high-complexity environments, control is never improvised. Sileme was designed precisely for that, to deliver total visibility where other technologies fall short. Sileme Life is the company behind Sileme, the advanced localization technology it develops and brings to market. A unique system able to operate reliably in highly metallic environments with no line of sight and with outstanding precision. From fixed assets to mobile resources and people, Sileme provides real-time visibility of their location, traceability and status. All managed from a single interface, visual, intuitive, robust. Sileme delivers unmatched reliability and exceptional precision, even in adverse conditions. Asset localization, access control, people positioning and guidance, immediate response in critical situations, a strategic, high-value innovation that empowers companies and institutions to be more competitive and secure. Reliability, safety, precision. Sileme Life. Limitless location.
Okay. Well, firstly, thank you to the organization and you, Roser, Anna, for this opportunity. Sileme is a disruptive technology of that we have developed in Skylife. Skylife is a company, a technological company that was created in the University of Seville 15 years ago. So a long time. Well, a long time, I'm not sure, but many years. And Sileme, the disruptive that is the technology is because you can use a location system in a metallic environment. This is something that really is, or the people say, no, this is not possible. Yes, with Sileme it's possible. Sileme works in this type of environment when one ultra wideband, I'm not sure, but here in the people can have an AirPad, no? Oh yeah, AirTag, sorry, one AirTag or something similar. I invite you that to locate one AirTag in a metallic box, and you will check that the signal is out. It's not possible to find this AirTag, okay? It's a fantastic technology, ultra wideband, Bluetooth, okay, fantastic. If you put this system or these tags or these items in a metallic area, this item disappear. It's not appear, okay? It's not possible to work. And with Sileme, yes. So with this advantage, that is a fantastic advantage, we can do a lot of things. For example, in industry, in defense, in mobility, really. We can optimize process. We can to find items, vehicles, assets in general, where other technology is not possible, okay? And also we can save life because, for example, in an emergency, it's possible that in an emergency you don't have any system at this moment that is working in a building or in one area, or GPS is possible that in this moment no work, okay? And with a very rapid or very quick deployment of our technology, we can locate the people that we have the tag. And this is something that can save lives. So for the reason, thank you to the organization, but I wanted to show you because I think that can be fantastic.
Okay, I think we are quite near to the end of the session, and maybe for the audience, could be a good idea to give a simple message, summarize our intervention to close that. So
So you want to start?
yes.
Be careful with good ideas.
It's okay. I think that we are talking about disruptive technology. We have seen very interesting technology to be used in critical situations. That is when everything has to answer. So I think it's really interesting. But we cannot forget the use. Why are we using this technology? In our view, as a national public administration, we need a mobility safer, resilient to face the challenges, and of course, connected, clean, and sustainable. But mobility is for people. So we need to focus to provide correct service for people, for citizens, to develop his real life in a normal way. So we need technology. There are really interesting new things that are running around us. We have to catch the moment and use it in the proper way, but we cannot forget what are we working for. So this is my message.
So I'll piggyback on your point. We have an example with hubs, with what I have presented, where as an airframer, we have done what we know to do, which is designing aerospace vehicles, right? And now we are in a point in time where we need to work in a collaborative way with users to understand the concept of operations and the challenges that users are facing to try to finalize our last step, which is the commercialization. How are we going to commercialize this type of technology, depending on whether we have in front of us a DGT, whether we have a defense user, whether we have a cartography entity or a firefighting body. So, and that's really like a call for users to help us define how we are going to market and what's the strategy here to define the concept of operation of this technology. And my last point, I could not talk about regulation because it's really what's stopping us a little bit now.
Yes.
So if there's any regulators in the room, I'll be more than happy to give you my visit card.
No, in my case, the message is that in our case is that, but in general, I think that the most important in the disruptive technology is that we have to create a real impact on the society, and we try to do that. But in the opposite or on the other side of the market, the users, especially the administration, we would like to a higher effort or more support to this type of companies similar than Skylight, because we are a medium company and we need this support from the administration or of that.
All
Okay.
right.
Okay.
I think this closes our. If we could put back my slides, I will just leave you the video so that you can see
fantastic.
the operations. Not the last one. There we are. There's some music, but I'm not sure if you have the music. voila. I didn't mention it, but it's fully solar, electric, sustainable technology, fully reusable. So the thing takes off land and takes off and land again. We couldn't finish without a green note, right?
Yes, it's a
Perfect.
fantastic finish.
So,
Thank you very much.
thank you very much to all
Thank
of
you.
you.